Preparing for the multiple choice paper, some interesting questions taken from the November 2011 paper, part 1. This question is asking you to identify various things on a graph, and there are a few exam technique points to take into consideration. So the graph is asking you to identify 4 factors. So the first thing to do is to work out what each line represents. So, the intensity of light per day, that's going to be low in winter and high in summer. So that is obviously going to be line B. Then the next one, number of producers, that's going to increase quickly and will then decline. Okay, that's because obviously as the number of producers increases, then they'll be eaten and etc. Then the number of primary consumers will follow the same trend as the producers, but with a slight time delay. So that is line D. And the quantity of the nutrients will decline in summer as the producer number increases, which is line A. So the answer, which is which curve represents the number of primary consumers, will be line D. This question is a really common question on a multiple choice paper that I've seen in a variety of different forms. You need to be able to calibrate the graticule so that then when you remove the stage micrometer, you know how much each unit of the graticule contains. So, step 1. 40 units on the graticule is 0.1 millimeters. Okay, now you know that because you know that this distance here is 0.1 millimeters, and that is obviously 40 units on the graticule. 50 to 10, that's 40 units. Then step 2, you need to identify the thing that you are actually measuring. So there is your nucleus. Step 3, how many units is the nucleus on the graticule? So that point you need to go, well, it's from there to there. Okay. So step 4, the nucleus equals 10 units. So 40 units is 0.1 millimeters. So 10 units is going to be 0.1 divided by 4 because 10 is 40 divided by 4. Which equals 0.025 millimeters. Now that isn't one of your possible answers, but 25 micrometers is, and 0.025 millimeters is 25 micrometers. This question has a lot of possible answers. Okay, there's a lot of information in this question. So the easiest thing to do is to identify an area where there is something that is wrong. Now, this column, there is not going to be anything that's wrong because that's just the name of the disease. Okay, a quick look down, this column suggests that there's nothing really particularly wrong with that. So now we're going to have a look at the treatment column. Now, obviously, AIDS is not treated with antibiotics, so that is incorrect. Cholera is treated with oral rehydration. Malaria is not treated with vaccination, and TB is treated with antibiotics. Okay, so then we need to go down the next line because we've got 2 things that are wrong, so we haven't identified anything there. AIDS is treated with a virus. Cholera is treated with bacteria. Malaria is a protist, and TB is not treated with a virus. Okay, so cholera is the only line where everything is correct. So the answer is B, cholera. This question is another opportunity to eliminate. So it's showing you a picture of a carbohydrate molecule, and it's asking you of which polymers could this be a part. So first of all, identify the key features of this molecule. Well, we can see that it's a 6-carbon sugar, glucose, and we can see that the hydroxyl group on carbon 1 is below the plane of the ring, so it's alpha glucose. You can also see that we've got a chain here and a chain coming off here, so it is branched. So what we know is we have alpha glucose and a branched molecule. So could these things be alpha glucose and branched? Amylopectin, alpha glucose and branched. Cellulose, no. Amylose is alpha glucose but not branched, so that's a no. Glycogen is branched and alpha glucose, but amylose is not. So by process of elimination, we're down with starch and glycogen. Now this is a funny one because obviously starch is made up of amylose and amylopectin, but amylopectin is branched and alpha glucose, and glycogen is branched and alpha glucose, so the answer must be D.